Thank you, Charles. Welcome to T-Exchange 2020. My name is Tom, and I'm very happy to present to you how we implemented Keycloak at Doodle. Let me introduce you to what we do. We schedule meetings for millions of users in almost every time zone. How many millions? 45 million users registered an account with us, and we have around 24 million monthly active users, meaning both with registered accounts and without. All these users, they were logging into their accounts via a custom authentication system. The system, while proven secure, caused some problems. For example, our engineers could not use common authentication protocols that they knew from previous experiences, or assessing its security compliance is difficult. Our customers wanted an easy way to integrate with our system. Without standardized protocols, this cannot scale. And also, our support agents were in need of better back-office tools to assist our users. How can we solve these problems? We need a modern authentication system. But we also had some constraints. We needed a gradual migration path for the products, not in a big bang release, but while being used around the clock. From the beginning, it was clear to us that we didn't want to implement security protocols ourselves. That leaves us with two options: SaaS or a self-hosted service. On the SaaS type, we have well-known options like Auth0 or Okta, but they come with a price tag of $1 to $2 per user per year. This means SaaS solutions are looking a bit expensive for a use case. So what about self-hosted solutions? There are very few full-featured options available, one of them being the Python-based project Glue, but we found our match with Keycloak. Keycloak comes with many features. It is an open-source project backed by Red Hat and has all the standard authentication and authorization protocols. It provides a lot of things out of the box, but can be extended and be deployed on our infrastructure. The journey. We started to explore a solution with Keycloak, reading the documentation, GitHub examples, and coming up with prototypes. Note about the documentation that I will come back a bit later seems not very approachable. There's a reason for that. But I know also it's hard to write good documentation. The main complaint, it being not very approachable. Okay, so how do we actually do the switch to this new authentication system? Let's talk about the problem of the source of truth. First of all, let's not share the DB between services. There are caching layers within each system. That's a bad idea. But we wanted to lazy migrate clients from the custom authentication system to Keycloak. During this migration, user data needs to be in sync on both systems. Keycloak has this mechanism for extensions called called service providers. Each type of extension implements its service provider interface, or SPI. One of the relevant extensions the documentation mentions is the user storage provider, which says that it is used for connecting to external user data stores. Seems like the right candidate. But we quickly saw some limitations. In order to have the full feature set of Keycloak, it needed to implement all storage details, including attribute management, group membership, role management, and credential management. The one thing we didn't want to re-implement ourselves. We went ahead and implemented a minimal feature set, so that called our custom authentication system to have up-to-date user data, namely user lookup, registration, and password validation. There's another component to Keycloak, InfiniSpan. It's kind of mind-boggling how little correct and up-to-date information there's out there regarding InfiniSpan and Keycloak. InfiniSpan is a distributed transactional key value store. This is used in an embedded mode in Keycloak to store all kinds of data, authentication sessions, action tokens, or distributed cache invalidations. However, it turns out the authentication sessions are not persisted by default, meaning they are lost when the service reboots and everybody gets logged out. That was an alarming discovery, but in the end, we managed, with the help of some mailing lists, to invoke a configuration script that told Infinispan to persist its data in a file. With Infinispan sorted out, we had a working prototype, and we wanted to know if it can handle more load. We created a Gatling test suite with login, sign-up, session tracking, and launched it against a cluster of 6 instances. This is where it hit us. This architecture cannot scale. We didn't even come near the volume of authentication calls we needed to handle the synchronous calls from the user storage provider to the custom authentication system being the bottleneck. So back to the source of truth problem. Keycloak, when having internal users, is way more full-featured. It has credential management, password policies, or different kinds of credentials like one-time passwords or WebAuth N tokens. So it would be preferable to have user data in the way Keycloak expects it and also manages. So we have last year transitioned to a streaming architecture at Doodle. And to tap into that architecture, we needed a mechanism first, to consume user data from Kafka, but also to report it back when it changes in Keycloak, so as to keep the source of truth up to date. Essentially, we wanted the inside-out database, and I refer to our last year's TX Exchange talk, moving to a streaming architecture from our director of engineering, Felipe, very highly recommended. After exploring some more source code, and there's a lot, we also learned a lot. Keycloak is very modular and uses these SPIs. All the extensions are using SPIs, but also a lot of core modules are using these interfaces. And we learned more about JBoss and Wildfly. Keycloak is built on top of Wildfly within the JBoss module ecosystem. Often, documentation has some brief reference if you want to learn more about subsystem configuration. Refer to the Wildfly documentation, which was also not very approachable. But finally, we discovered that all these Wildfly applications had a management UI for the configuration, which for us really connected all the dots. Especially, we saw how we can override the default persistence provider for Keycloak users and basically hook into user data changes and being able to report them. Okay, so now we have a plan. We can connect Keycloak to our streaming source of truth, Kafka. We can inherit all the user provider functionality. We can hook into its implementation and report back to the custom authentication system when user data is mutated through Keycloak. We can also implement a new SPI for Kafka consumers. And we just need to make sure that the Kafka consumer is also invalidating local caches in Keycloak. You might notice there might be an architectural problem here. We have to be really careful to not create an asynchronous message loop. User data changes coming from Kafka must not be reported back to the custom authentication system. So how to write a custom SPI? We had to essentially relearn Kafka. Yes, we're mostly a Java-based backend, and we mostly develop our services in Spring Boot. Spring Boot does a lot of heavy lifting for you in terms of configuration. We didn't have Spring Kafka consumer and needed to drive these consumers ourselves, like the retry topic mechanism or offset committing. About extending this default persistent provider, we didn't change any of its implementation. We inherit all the functionalities around user storage, credential management, identity brokering, and so on. But we just hook into the right places to report back and be careful about the asynchronous message loop. Remember the authentication session cache debacle? In our previous deployment, it was embedded into Keycloak. This was problematic for a couple of reasons, but mainly one being booting time. When you need to load gigabytes of persistent cache data when booting, deployment procedures become somewhat problematic. We managed, thanks to our awesome DevOps team and our new understanding of the JBoss world, to externalize InfiniSpan in its own deployment, complete with high availability and monitoring. The deployment. So when you consume 47 million user records, we noticed a couple of problems. Like, first of all, our test data set was just a fraction of this volume. And we discovered new edge cases. Especially, it also takes time to consume all this. And the database needs a bit a boost on the AWS to handle this continuous load. Also, learning from load testing, we did tests with hundreds of thousands of users, but it turns out that at scale, databases can easily handle unoptimized queries. And we found this can manifest in severe performance degradation above 500,000 users. So we needed to add the missing indexes in that database schema. Also, more realistic test data for edge case detection. For example, external identity providers. They are not under our control and may trigger brute force detections. But while stressful after such a long journey, with an awesome team, we managed to overcome these final hiccups, and today we are in production. More specifically to the problems we had at the beginning, our engineers are now using standard security protocols for our new products. Enterprise customers already are using OIDC for integration with our API, and new back office tools are available and being used by our support agents. So, is Keycloak ready for such a use case? Definitely yes, but you have to realize a couple of things. First, it's not Spring Boot, it's JBoss and Wildfire. It's a different world. We need to relearn these patterns. These ecosystems have been around a long time, basically before containerization. So they have a couple of different approaches as well. The database schema needs a bit of tweaking with the indexes, and InfiniSpan really needs to be replaced by something more well-known like Redis. And finally, we need also a more approachable documentation for extension writing. So all these deep dives, learnings, developing together, and debugging in pair programming sessions has forged this team together like I've never seen before. So a special shout out and thank you, Maggie, Petko, Cox, Easy, and Gurki. Thank you. If you want to know more, here is also my bookable calendar link and my email. Thank you very much.